Okay, so the first gas law that we're going to be learning how to do some calculations with is called the combined gas law. And this podcast that we're going to cover the combined gas law in is just going to kind of get you started working with it. So we're going to do the bottom of page 3 where we get to know the law and the first 3 example problems, and we'll pick up from there in class next time. So what is the combined gas law? Well, it's this big equation that has all of our units combined together, all of those properties that we've been measuring combined together into one equation that's going to help us predict how these variables, pressure, volume, temperature, that we've been talking about are going to change in more complicated situations than we've seen so far. And you can see we've got the same variables on both sides of this equation. It's just that one side has 1's on it and the second side has the same things, just with the 2's on it. So this is kind of your before side and your after side. So the conditions before our change and the conditions that we have after the change happens. And in addition to that pressure, volume, and temperature that we've been talking about, there's also an N in there, and N does stand for moles. So when we change the number of moles of gas in a container or in any kind of sample, that could also affect our pressure, volume, and temperature. But honestly, we don't end up seeing that change that much, but we'll talk about that in a moment. Now, the first thing I want to tell you about this equation is that it's going to be given on your equation sheet, and I'll pass those out to you in next class. We'll definitely get used to working with that this unit. You do not have to memorize this equation, just have to know how to use it. And when it comes to using it, it really is mostly just plug in the numbers and solve for what you don't know. One of the most important things to remember when we're plugging in the temperatures into this equation, like I already told you before when we were talking about how to do those initial temperature conversions, every single temperature that you plug into this equation has to be in Kelvin. Most of the times you're going to be given that number in Celsius, so you've got to change that Celsius to Kelvin before you start plugging it into this equation. Now, I'm going to talk more about these kind of bullet points about how we solve it. We're just going to cross multiply, then divide. But another important thing for how we set it up, even before we start doing the math, is as you're reading through the problem, you've got to be able to pick out what variables are which. And if the question either says that a variable does not change, or if it's just not mentioned in the problem, we don't put it in the equation. So even though this equation seems pretty big and complicated and there's a lot of things in it, if the question mentions that volume is held constant, then we could remove the volume from this equation, and that simplifies it. Moles tend not to change. We haven't talked about them changing so far, and a lot of times they just don't change. So a lot of times we're going to be leaving the N's out of this equation. And it could be that the volume and the moles are left out. They're not changing. So that could simplify this down to just P1 over T1 equals P2 over T2. So each question you're going to have to read critically to see what numbers you're given, what is changing and what isn't. But it's actually easier if something just isn't mentioned, or you see that it says it's constant, you get to leave it out. It simplifies your math a lot. So when it comes to calculating this, I use the words cross-multiplying, and hopefully you recognize what that means. But in general, what that means, if you don't remember, some people were taught that this is called the butterfly method. We multiply across diagonally with these two fractions. So you take the P1 times V1 times N2 times T2 and set that equal to N1 times T1 times P2 times V2. Basically, this big, crazy looking equation. Now, you shouldn't have to write down this pink and blue stuff, this equation here, because remember, we're not always going to see all these variables. So I don't want you looking for them, trying to plug them into this, especially since this equation isn't given. You need to be able to cross-multiply with whatever numbers you are given. So let me show you for an example. Let's say I read through my problem and I ended up with these numbers in these places after plugging them in. And we'll go through the process of finding numbers and putting them in the right places in just a moment. Well, in going about solving this, I would multiply across this first diagonal, 3 times P1 times 6, and set that equal to 4 times 18. Now, in general, I would recommend that you kind of combine the like terms, combine the numbers that you know on each side. And for context, this is maybe I'm trying to look for and solve for what is my initial pressure here? What is my P1? That's why I've left it here. We have to leave the thing we're looking for in the equation. We don't have a number for it, but by solving everything else, we're going to end up with a number for it. So we leave that as part of our equation, and as we're crossing, we keep that with the 3 and the 6. Now we're just going to combine that 3 and that 6 together and multiply that 4 and 18 together just to simplify that expression. And we get 18 times P1 equals 72. And now at this point, we're going to divide by whatever is with what we're looking for, because we want to figure out what P is on its own, not what 18 times P is. So we'd be dividing by 18, and in order to keep this equal, we've got to do the same thing on both sides. So the 18 cancels out, and P is going to be equal to 72 divided by 18, which is 4. So we cross multiply and divide. And a lot of people cross multiply and kind of condense, simplify, and divide, but you can kind of go through whatever algebra steps you want to in between that cross multiplying and divide, whatever you need to be confident in that answer. So let's take a look at our first problem. And the first step, as you're reading through the problem, like I've already said, is to identify what numbers you've got and what variables we're going to be plugging them in for. And sometimes they almost label themselves, but sometimes it's a little trickier. So here it says, if I initially have a gas at a pressure of 12 atm. So it told me that's a pressure, so I'm going to go ahead and label that P. And since it's my first pressure, that seems to be my initial conditions, we'll call that P1. And a volume of 23 liters. Well, this is our volume, and since it goes with our P1, that's our V1. And a temperature of 200 K. That's going to be our T1. Then I raise the pressure to 14 atm, so that's going to be my P2. Increase the temperature to 300 K, so that's my T2. And it's asking us to find the new volume. So we're going to be looking for V2. So these are the variables we're going to be putting together into that combined gas law. And let me put that equation up here up top, just so we can use it as a guide as we're plugging these numbers in. And so as we start to put stuff together, we're going to put our P1 and our V1 together on top, and they are being multiplied together, but we can leave that math for later. Then we don't have an N1, so we're just going to leave it out. It doesn't say moles are constant, but it just doesn't mention moles at all. So we just need to put that T1 down on bottom. Then P2 is 14. V2 is what we're looking for, so we have to put it in our equation because otherwise we can't find it. If we don't write that V2 there, that's kind of like playing hide and go seek with your friends when your friends aren't even there. You can't play hide and go seek unless they're actually there. They're just hiding amongst all the rest of the numbers. We're going to find them and uncover them from all of those other numbers. So this is the way that we're going to start with the numbers all set up. So it's cross multiplying time. So we're going to multiply across our first diagonal, 12 times 23 times 300. And then we're going to multiply across the other direction, 200 times 14 times V2. Remembering to keep that V2 with those numbers in its diagonal. Now you probably would want to condense these down and kind of figure out what is all of this pink stuff multiplied together, just to simplify our expression. So I went ahead and did that here. I just kind of moved it up since I couldn't kind of keep moving down. So I just multiplied all the pink stuff and the blue stuff together. And now in order to solve for what we're looking for, the V2, we have to divide by whatever number is over there in the way of having V2 on its own. So that would cancel out and leave us behind the V2. And this math should get us our final answer. And that ends up being 29.57. And I guess there's some more digits there. Now, when we're talking about rounding this final number, we really have to look back at all of our original numbers that we put together to see how many sig figs we should round it to. And remember, we always round to the least number of significant figures. So even though these temperatures were 3 sig fig numbers with those decimal points at the end, because I had some 2 sig fig numbers in here, I just want to round this to 2 sig figs. And the 5 is going to round my 9 up. So this is going to turn into 30 with a decimal liters. Now, I know the unit for this volume is liters because the other units for the other volume is liters. Basically, these units are going to match. So we can use our V1 units to figure out what V2 is going to be. Another way of looking at this is that they have to match. If we're going to plug them in as our V1 and V2, or even our P1 and P2, they have to have the same units if they're being plugged in for the same variable. So we can use that fact to help us. So hopefully that wasn't too hard. Let's do another couple of examples real quick. Okay, so here we have a gas that has a volume of 28 liters, so let's call that V1, a temperature of 45 Celsius, that is our T1, but because it's in Celsius, we want to change that into Kelvin. I would recommend you do that almost as soon as you find those numbers in Celsius so that you do not have a risk of plugging them in wrong. Remember, we just add 273 to any of those Celsius numbers to turn it into Kelvin. And an unknown pressure. So we're going to be looking for that original pressure later on. So that P1 is going to be our unknown variable. And we have our volume increased to 34 liters, so that's going to be our V2. Our temperature is decreased to 35 degrees Celsius, which plus 273 is 308 Kelvin. If I measure the pressure after the change to be 2 atmospheres, so that's our P2, what was the original pressure? So that's, again, when I realize that P1 is what I am looking for. So, plugging all of this stuff in to our equation, we're going to have to write our P1 there. That's what we're looking for. And then our V1 is 28. Our T1 is 318, P2 is 2, V2 is 34, and T2 is 308. So, time to cross multiply and divide. So we're going to multiply all together this P1 times 28 times 308, and then do the same thing with 318 times 2 times our 34. Wow, that's not what I thought it was. Now we can combine the pink and blue numbers together to simplify things. And so condensing it all together, we end up with 8624 times that P1 that we're looking for equals 21624. And if we're trying to solve for P1, we need to divide by whatever is there with our P1. And if we do that on both sides, then it cancels out on the side that we don't want it on, leaves us that P1. And this should be the final math we have to do to get our final answer. And our P1 here is equal to 2.507. There's some more numbers there. Looking back at our givens, once again, 2 sig figs is the least number of sig figs that we have. So 2.5 is our answer. If we look back at the other P value that we have, that was in atmospheres, those ATM. So 2.5 ATM is our final answer. Let's do one more example here. If I initially have a gas at a pressure of 12 ATM, that's going to be my P1. A volume of 23 liters, V1, and a temperature of... That's seeming a little too similar. This is not example 3. I'm looking at example number 1. Pause for a moment. There we go. That looks a little more like example number 3. Okay, so if I have 21 liters of a gas, and this is where it gets a little bit tricky because it doesn't tell you what that is. That's where we have to be recognizing these variables that we've been learning. Liters is a measure of volume, so that's our V1. And we're held at a pressure of 750 kPa. Remember, pressure has lots of different units, so I'm glad it told us it was pressure. That is our P1. And a temperature of 900 K, so that's our T1. What will be the volume of the gas? So we are looking for volume 2 if I decrease the pressure and temperature to STP. And it doesn't really give us anything else. It doesn't really give us any other two numbers. But that STP letters, if you remember from our last podcast, is what standard temperature and pressure is abbreviated as. And STP tells us that we need to go and find what is that standard temperature and pressure so that we can use those as our P2 and our T2. So that's kind of a sneaky way of giving us our T2 and P2 in order to be able to work this problem out. So if we go and look at that real quick, maybe flipping back to look at the top of your page 2, where we define that standard temperature and pressure. Our standard temperature is always going to be 0 degrees Celsius, which hopefully we have already edited and removed and crossed out those decimals there on your number, which is always 273 K. So 273 Kelvin is going to be our T2. Our standard pressure, these are all equivalent, but we don't have a choice in which one to use here. We need to make sure that when we plug in our pressure values, that the units always match. So because in the problem we're trying to solve, our P1 is in kPa, we need to make sure that when we pull out our standard temperature, it's also in kPa. So we're going to be using this 101.3 kPa as our P2. So coming back over here, let's go ahead and write down our P2 as that 101.3 kPa, of course, and our T2 as 273 Kelvin. And from here, the rest of this problem is pretty much normal. We just got to plug those numbers in where they belong. So 750, 21 over 900 equals our 101.3 times the V2 that we're looking for over our 273. And now as we start our cross-multiplying process, got to multiply all of these numbers together and all of those numbers together. I'm not going to write down that math this time. You can actually just start by plugging those numbers into your calculator. Instead of writing them down, you can already kind of see which numbers you need to multiply. So go ahead and start by just multiplying those three pink highlighted numbers together, and that's going to get us 4299750. And then we're going to multiply all of those blue numbers together, and that gets us 91170. And that's where our V2 goes. And we wrote that now that it fits a little bit better. And then we just need to divide by that number that's there next to with the number that we're looking for, that V2. So this cancels out. This should give us our final answer. And I got 47.16. Looking back at my givens, 2 sig figs seems to be how many we need to keep. So my final answer is 47. Looking back at my other V value, it's in liters, so this should be in liters. So we'll pick up from there in class next time.